Hello and welcome to my channel. Today I'm going to be showcasing how to make your own TCP server using the C language, obviously because I hate myself. So first things first, we're going to import like 10 different libraries just so we can have all the structs and all the functions. So we're going to need ARPA, inet, and these are all on Linux libraries. So if you're on Windows, I'm so sorry. Um, yeah, Linux is better. So the first process of setting up a server is configuring our local address. So we're gonna create a struct called adder info, called hints. Mem set it to all zeros. Then use the size. I'm making a lot of errors. Okay. So after we mem set it to all zeros, we can actually start setting it up. We can say hints AI family. And the flag is going to be a passive. So now we're going to create another adder info struct and bind address. Okay equals get adder info. So in here, we need a name, 0, 8080 for the port. Um, hints, and then bind address. Um, get adder info either returns a 0 or anything but a 0, and it's an error. So if k is not equal to 0, we can do an fprint str. There's going to be some cases like this here, so we'll probably come up with a function to do this, but I'm just lazy, so I'm just going to probably copy and paste those. So now we create our socket. And we have all our bindings, so we can do bind address, import to AI family, pretty much everything we need. Boom. Socket actually returns a file descriptor, a valid file descriptor. So if it's right, everything's correct, we're gonna get a file descriptor. So you can check for error handling, but we're not gonna do that just because it's a quick video. So bind socket to address. So we're gonna be doing if bind socket listen line address AI adder info line address AI adder length. Yeah, pretty much just copy and paste that. Oh, we have to yank it. Error occurred in bind. Okay, so now we're gonna wait for connection. So sock adder storage supports both IPv4 and IPv6. So here we're gonna call this client adder, and then sock len t be client line equals size of line adders. Okay, now in socket client equals accept. Actually, we still have to listen, I believe. Yeah, we still have to listen. And we never free adder info. Yeah, I kind of got ahead of my own self. So actually, after binding the socket, we can free adder info, just because we're not going to reuse it. So we don't get any memory leaks. And now we're going to listen for connection. So we're going to call if listen. All it needs is a file descriptor, so sock listener. And then we're going to do like 10. Okay. So we're listening for our connection now, and now we wait for our connection. So here we can actually store our, or we're gonna make a buffer where we're gonna store all the addresses. But now we can say in socket client equals accept socket listen. And this is gonna be accepting that connection that comes through that we're listening for. So we must say socket, and here we have to typecast. Let me just execute it first, and I'll explain why. Okay, so we're typecasting client adder, which is by default in sock adder storage. So that's a struct by default. It is compatible. So I read the docs and it is compatible, so we can do this typecast. And if you look at them, they're actually very similar. So let's see. Um, they have actually very similar structures, so you can typecast them. So after typecasting, uh, we can actually say char address buffer, or we can store all the addresses and then get name info. And get name info, we'll have to pass again onto our client adder. Then we need our client lane and address buffer. So we're just going to size of address buffer 0, 0, and then numeric host. Okay, and then we are actually able to print it out as well. So that's cool. Jesus Christ. Address buffer. So we're actually not going to be able to print out much. This is just going to print out the address which we're connecting from. Let's actually get the request. So depending on your browser, the requests will look different. So bytes receive. We can call receive now. It takes in a file descriptor, and our file descriptor is our socket client, which we accept here. So we can call socket client. Then it takes in the buffer, which is going to be our request. Size 24, 0. And now we should be able to actually print it out by using some string formatting and do this. Where's the pointer? Jesus Christ. And then we do bytes received, and then we do request. So we'll print it out accordingly. So if we run this right now, let me go ahead and compile this. So it's just gonna wait, and it's gonna wait until you open your browser, go to localhost, type in 8080. So it's gonna say unable to connect, but we actually do catch the request anyways. And you can see where our printfs happen. So right here is the address buffer, and then right here it starts printing out the start printing out the request. So now, if we actually want to be able to create a whole connection, we need to send a response back. So to do so, all we have to do is just say const char resp. And this gets a little tricky. I'm just gonna copy a response I already have. It's quite long. But it would be like HTTP 1.1 200 for the code, and OK /r/new, and then we would keep on going. Content type, and just like a basic HTML request. So here's my request that I wrote. It's a couple of lines, and basically all it does is just says hello world. Oh, actually, I won't do that. Let's do a body here. H1 hello from C. Okay, so now we have to send the request, right? So in bytes send equals send. We need our file descriptor. So that'll be our sock client. Then our response that we're sending. Then we need the length of the response. So str len, and then do it on the response. And then for flags 0. And this should be it. So let's go ahead and compile. Execute it. Head to our browser, refresh. We get our hello from C, and the whole request goes through. So thank you for watching. Please leave a like, subscribe, and request some sort of videos that you'd like me to do. I'm sorry for not uploading for a little bit, just busy with schoolwork.